Hello and welcome. Today I want to share with you an interesting problem. It is stated like this. Leonardo da Vinci wrote, when each of the two squares touch the same circle at 4 points, one is double the other. So we have a circle and there are two squares. One square is inside the circle and other is outside, and the relationship is like this: one is double the other. All right, so that's what we are trying to prove. So you can take a minute, pause this video and try to figure out, and after that you can come back and see. So let us look at the question now. We have circle and then I got one square here. This square is touching the circle at 4 points and it is outside. Right, now take the second square. This second square is also touching the circle, but it is from inside. So these are the two squares. Now our task is to show that this bigger square is double the area of the smaller square. Now we all know the formula for the area of a square, which is side times side, side square. Side square is the area of a square, and we also have another formula to find the area of a square, that is the diagonal square divided by 2, or half of the square of the diagonal gives us the area of a square. So in order to prove that statement, we have to make use of both of them. So let us use these two formulae for finding the area of a square. So I'll start from the one that is inside. Now let me draw a diagonal to that smaller square, and I'll write it down here. This is the diagonal. Okay, so area of this smaller square, area is equal to 1/2 the square of the diagonal, that is d square. All right, so now you have the area of the square that is inside the circle. Okay, all right, now if you pay close attention to this diagonal, you can see that it is also the diameter of the circle. This diagonal is the diameter of the given circle. That is the big thing here. All right. So what I'll do now is just draw one line. This is the diameter. That is the diameter. And in a circle, from wherever you draw diameters, all the diameters are congruent. Their measurements are equal. So the diagonal of the inner square, which is the diameter of the circle, right? And if you pay further close attention to this, you will understand, you are going to see that this diameter is also the side of the square, the side of the outer square, in fact. And what is the measure of this diagonal? We considered that to be just a d, right? This is your d. Okay, this one is d, the diameter and the diagonal. Even the measure of this side is also d. But in this case, it is the side of the outer square, and its area is equal to what? The area of outer square, I can say. Outer square is equal to side times side, that is side square, which is d square. So did you get the point now? the area of the inside square, it is half of the square of D. Alright. And the area of the outer square is D square. And what is the relationship between those two areas? Look at this. The outer area is twice the area of the inside square. That's all it is. So the thing is, make use of those two formulae for the areas of a square. Just one is a half of the square of the diagonal and other is the side square. And try to connect that with the diameter of the circle. Okay. I hope you enjoyed this problem and it created some interest in you to learn more about this circles and squares. And please try to prove this differently. Instead of taking a diagonal and the diameter, is there any other proof to this? Okay. Thank you. Thanks for watching.